Maximum height. A vertically projected body moves up. While moving up, its velocity will be reduced, and at one stage, its velocity becomes zero. The height attained by the body before this velocity becomes zero is known as maximum height. The height attained by a vertically projected body before its velocity becomes zero is known as maximum height. We can derive a relation for maximum height. For this purpose, let us take initial velocity of projection as u and final velocity v is equal to 0, displacement s is equal to capital H. If we consider upward direction as positive, then a will be acceleration will be equal to minus g. So u is u, a is minus g, v is 0, s is equal to h. Let us substitute these values in the relation v square minus u square is equal to 2as. Then 0 square minus u square is equal to 2 into minus g into h. Minus value gets cancelled on both the sides. So we will get u square is equal to 2gh, from which we will get h is equal to u square by 2g. This is the relation for maximum height. H is equal to u square by 2g. Relation for time of ascent. Time of ascent is the time taken to reach maximum height. To find a relation for time of ascent, let us consider initial velocity as u and final velocity is 0. Acceleration a is equal to minus g. Time t is equal to ta, where a stands for ascent. Let us use the relation v is equal to u plus at. In this relation, we substitute u is equal to u, a is equal to minus g, v is equal to 0 and t is equal to ta. Then we will get 0 is equal to u minus gta. 0 is equal to u minus gta, or gta is equal to u. Therefore, ta is equal to u by g. ta is equal to u by g. This is the relation used for finding the time of ascent. Time of descent. Time of descent. It is the time taken by a vertically thrown up body to reach ground from maximum height. The time taken from maximum height to the ground is known as time of descent. The maximum height is u square by 2g. So this problem can be solved by imagining that the body is falling freely from a height h is equal to u square by 2g. So it's when an initial velocity u becomes 0, acceleration a is equal to g, s is equal to h is equal to u square by 2g, t is equal to td. Let us take the relation s is equal to ut plus half t square. In this relation, let us substitute u is 0, a is equal to g, h is equal to u square by 2g and t is equal to td. Then we will get capital H is equal to 0 plus half g td square. U is 0, so u2 is 0, ut is 0, so we will get h is equal to half g td square. But h is u square by 2g. So u square by 2g is equal to half g td square. Then td square is equal to u by g, u square by g square. Td square is equal to u square by g square and td is equal to u by g. Td is u by g. Time of flight. Time of flight. It is the time for which the body is in air. That is time of ascent plus time of descent. This is the total time for which the body is in air. Ta is u by g and td is u by g. So capital T time of flight is equal to Ta plus td, that is equal to u by g plus u by g is equal to 2u by g. Time of flight is 2u by g. Definitions. Define the following: maximum height capital H, time of ascent Ta, time of descent Td, time of flight capital T. Capital H, maximum height. The height at which the velocity becomes 0 is known as maximum height. The height at which the velocity becomes 0 is known as maximum height. Ta, time of ascent. The time taken to attain the maximum height by a vertically projected body is known as time of ascent. The time taken by a vertically projected body to reach the maximum height is known as time of ascent. TD, time of descent. It is the time taken by the vertically projected body to reach ground from maximum height to the ground, that is TD. Time of flight, capital T. It is the time taken by the body to remain in air. The time for which the body remains in air, that is time of ascent plus time of descent. The total time for which the body is in air is known as time of flight. Velocity on reaching the point of projection. Velocity on reaching the point of projection. This can be calculated by considering the downward motion of the vertically projected body. That means the body is traveling from maximum height to the ground. So it can be considered as a freely falling body. So its initial velocity u is equal to 0. The displacement s will be equal to maximum height h, which is equal to u square by 2g. The displacement s is equal to maximum height, which is equal to u square by 2g, and acceleration a is equal to g, and final velocity is how much? We have to find final velocity. The relation between u, a, s, v is v square minus u square is equal to 2as. V square minus u square is equal to 2as. Therefore, v square minus 0 square is equal to 2g capital H, or v square is equal to 2g capital H. But capital H is u square by 2g. So v square is equal to 2g into u square by 2g, which becomes equal to u square. Hence, v is equal to u. So the body returns to the ground with the velocity u, but the direction of the velocity will be in the downward direction. Initial velocity, projected velocity is in the upward direction. The velocity of reaching the ground will be in the downward direction, but its magnitude is u. Velocity on reaching the point of projection. This can be derived from another point of view. Let us suppose the velocity of projection is u. If the body returns to the ground, then its displacement will be 0. If we consider initial velocity as the velocity of projection, on reaching the ground, its displacement becomes 0. So let us calculate final velocity. Let us consider the upward direction as positive, initial velocity direction as positive, then the acceleration a is equal to minus g. So we take u is equal to u, a is equal to minus g, s is equal to 0, and v is how much? From the same relation, v square minus u square is equal to 2as. V square minus u square is equal to 2 into minus g into s is 0. So the right hand side becomes 0. Therefore, v square is equal to u square. V square is equal to u square, or v is equal to plus or minus u. V is equal to plus or minus u. Plus u is the velocity of projection and minus u is the velocity of returning to the ground. Minus u is the velocity of returning to the ground. Vertical projection from the top of a tower. Vertical projection from the top of a tower. First, let us try to understand the figure. Let AB be a tower, B is top of the tower, and A is foot of the tower. From B, suppose a body is projected vertically upwards with a velocity u. Suppose a body is projected with a velocity u vertically upwards at the top of the tower B. Suppose it reaches the maximum height. It reaches the maximum point C, which is at a maximum height from the ground, and it then returns. Actually, it comes along the same path, but to have an understanding, I have shown the path to be separate. So CD is the return path. CD is the return path. The height of the tower is small h. The height of the tower is small h. And the acceleration due to gravity is in the downward direction. Now, in terms of the parameters. U is equal to u, that is we are considering upward direction as positive and initial velocity as u. The displacement s becomes equal to minus h. Be careful here. The displacement is from initial position to final position. The initial position is top of the tower B and the final position is the ground D as ground. So the vector is situated from top of the tower to the bottom of the tower, that is minus h. Since height of the tower is h, direction is opposite to the velocity direction. So downward direction will be negative, hence s is equal to minus h. So acceleration will also be equal to minus g because we are considering upward direction as positive. So a is equal to minus g. Let t be the time taken to reach the ground. That means the time taken to go from B to C and then from C to D, the total time is taken as t. Then let us take the relation s is equal to ut plus half a t square and substitute the above values. U is equal to u, s is equal to minus h, a is equal to minus g and t is equal to t. Then we will get minus h is equal to ut minus half gt square. Minus h is equal to ut minus half gt square, or h is equal to half gt square minus ut. H is equal to half gt square minus ut. This is the relation which we can use for solving the vertical projection from the top of a tower, the problems concerning vertical projection from the top of a tower.